Okay, so we're looking at this question here. So for real values of x, f of x is defined to be the minimum of 4x plus 1, x plus 2, and 4 minus 2x. Okay? And the question is, what is the largest possible value of f of x? Okay? And we've done all this working to solve the problem in the class, but we want to figure out how to write the proof. Okay? So you might notice that the actual proof is very different than what we actually did to solve it. Okay? And one key difference that's kind of predictable is it's kind of backwards. Okay? It's kind of backwards. So why is it backwards? Well, we got to the answer at the end, right? But in the proof, we write it first. Okay, so we write the maximum. See, the maximum might not even exist, by the way. Okay, so in some sense, the question either is assuming that it exists, or you might have to even prove that it exists. Okay, so at the start, you write what your answer is. Okay, the maximum value is 2 plus 2/3. Yeah. Or, if you're in primary school, you can write 2.6 repeater. I remember when I first learned that, I was like, what the? That dot represents infinitely many sixes. Okay. So 2 plus 2/3, right? Okay, so what would you do? Well, you want to show that it actually is a value, okay? Right? So in some sense, you're proving it exists at the same time. So you show that it can actually have the value, and then you prove that it can't have a bigger value, right? So the first step is very obvious. You do f of 2/3, right, equals the minimum of 2/3 times 4 plus 1, 2/3 plus 2, and 4 minus 2 times 2/3, right? And yeah, then you notice, the minimum value is 2 and 2/3. It's what?
I think it's 1 and 2. Wait, 1 and a third. No,
1.
2. I mean, 4 minus 1.
4 minus 1 and a third. So this is 2 and 2/3, right?
Oh, yeah.
And this is 2 and 2/3, and this is bigger than 2 and 4. So it equals 2 and 2/3. Yeah. Okay. So it actually has a value of 2 and 2/3. Yeah. Okay. And then we just got to show all the other values of x is smaller, right? So when we show f of x is smaller than equal to 2 plus 2/3. So now we show for all x. Yeah. I won't spend too much time on this because you have like a Zoom session as well for this. I think, right? You know about the Zoom session, yeah? There's some Zoom session where you go through the answers of the exam that Andy's organizing. Anyway, so if you want to know about that, I can find the email or something. But just yeah, okay. So then show f of x is less than or equal to 2 plus 2/3 for x, right? And so the key, I think here it might be easier to break it into cases. So what's an easy breakdown of cases? So, for example, if x is bigger than 2/3, maybe that could be a case, yeah? So if x is bigger than 2/3, so x is bigger than 2/3, yeah? Then 4 minus 2x is less than 2 plus 2/3, right? Then 4 minus 2x is less than 4 minus 2 times 2/3, right? Which is 2 plus 2/3, you know? And so if 4, and we know that f of x is less than or equal to 4 minus 2x, right? So maybe the right way to write this is we write f of x is less than or equal to 4 minus 2x is less than 4 minus 2 times 2/3, which is equal to 2/3, 2 plus 2/3, so therefore f of x. So yeah, you can even do greater than or equal to here. Is less than 2 plus 2/3, right? That makes sense? Okay, well, what's the other case? Well, the other case is x is less than 2/3, yeah? So if x is less than 2/3, then f of x is less than or equal to x plus 2, right? Is less than 2/3 plus 2, yeah? And that's the whole proof, yeah? Can you see how crazy that is? The solution, I mean, it looks as messy as the proof, but the proof is actually much less messy, okay? So it's kind of like the solution was all this other stuff that we even said and didn't write down, okay? But if you look at the proof, you just take the essential part of the solution and you write it down. All right. I'll type this up maybe.